All right, so now we can name something, but how do we place it in relation to everything else? And that's where we're going to start making cladistic trees. We have to talk about how to build these trees. Phylogenies are a proposed evolutionary history of a group of species. All of these are different organisms. Surprise! They can be looked at in relationship to each other. Which of these would you say is most similar? Which is the most different? Which would you place as an outgroup? The jellyfish? All right, so we put the jellyfish at one end. We put a little line coming down from it, and everything else branches off of it. What's the next most weird? The frog? Okay. All right, so we've got this Nigerian, the jellyfish, we got the frog related to each other. What's the next weird one? Here's a flatworm, here's a roundworm.
The spider.
The spider?
I don't know. That's a starfish.
Yeah, that's a starfish. So do you starfish or the spider? You want to have the spider and the starfish closely related because they have a lot of legs? Yeah, we'll do that. We'll make them really closely related to each other. There we go. How about these worms over here? How are they related to each other? This one, that one, and that one?
Yeah.
They're all together? And they probably all branch off of, I don't know, that Nigerian over there. You have this complex structure that begins to form. You have one hypothesis. You have another hypothesis. Depending on the taxonomist, you can have different hypotheses based on different attributes, based on differences in human evaluation. It's going to be really important when you see these phylogenies not to take them as the truth. They are a proposed explanation. The taxonomist is putting out what they feel is the best choice, but it is entirely based on what they have decided are the most important qualities of that organism. So it's a hypothesis, and it's still just being confirmed or refuted. What I will have you guys do is create phylogenetic trees. You're going to look at organisms, and you're going to decide how those organisms are related to each other. You're going to start classifying things. When you're looking at a phylogenetic tree like this one, this is the evolution of the forest ape. Typically, the y-axis is time. Remember, y goes up and down. X-axis is divergence, or the amount of variation between the species. So we start off down here at the forest ape. How long ago was the forest ape around? About 8 million years. Over time, you get a split. You get a gradualist movement over to the gorilla, and then the group that's going to be the chimpanzees and the humans. Let's look at just the chimpanzees and the Homo line. When did the split between chimpanzee and Homo occur? About how long ago? About what? Yeah, how many? 6 million years ago? You get a split. And you'll notice that they go off and they start to go all over the place. What do each of these dead ends mean? Extinction. That's a stop. So with the Homo lines, you're going to see a lot of, because Homos are really competitive. I'm not sure if you noticed about people, but Homo is really competitive. Where you have a split, there's a lot of competition, and those organisms are going to be in conflict for the same resources. We go farther and farther up. Homo erectus goes off to become the Neanderthals. Homo sapiens goes off in a different direction. Split and split and split. That is a phylogenetic tree. Are we more closely related to gorillas or chimpanzees based on this tree? Chimpanzees. Questions? All right. We saw two things happening in that phylogeny. You saw the gorillas going off in one direction for a long time without many changes. That's called anagenesis. You're evolving into a new species over time gradually. It's an application of gradualism. That's compared to what happened with Homo sapien and Homo erectus. You had cladogenesis occurring, where you have one species diverging into two unique ones. So anagenesis is where you've got a line going for a long time all by itself, becoming a new species. Cladogenesis is where you have a clade formed, or a group. At the base of each branch in the phylogeny is a node that shows where that cladogenesis occurred, where that common ancestor is found. These groups are called clades, C-L-A-D-E. If you look here, we've got different examples of clades. This over here, these two organisms are a group. They are clade 1. They're just a group. You can look broader. The individuals in this yellow box, they are clade 2. They're a group. They're considered a clade. And then finally, this whole thing is considered a clade. Or this group is considered a clade. A clade is just another word for groups of organisms. So the modern taxonomist works at figuring out clades that reflect ancestral organisms, the common ancestor. Figuring out what organism goes in what clade. There are three types of phylogenetic groups: monophyletic, paraphyletic, and polyphyletic. What does mono mean? One. The monophyletic group is the one that you probably will understand the best. It is a single common ancestor and all of its descendants. Here is a monophylogeny. Here is a monophylogeny. One common ancestor, all the descendants. In fact, this whole thing is a monophylogeny. All the common descendants from that one ancestor. It includes every single one of them. That's like, I guess, your real family tree. You, all of your every single one of your descendants. A paraphyletic group is a common ancestor, but not all the descendants. Here's the common ancestor, and it includes most of, but not all the descendants. That could be a clade, a grouping. Think about, there's always that one person in your family who you're like, they're not related to me. You know who I'm talking about. I don't need to go into depth about who it is. I'll go into depth about who it is in mine. It's my Uncle Larry. I was just like, I'm not related to that dude. He is a jerk. And I'm a pretty big jerk, but he's like bigoted, racist jerk. And I'm like, nope. Out of the family. Everybody else can stay in the family, but we don't acknowledge that one. That's a paraphylogeny. When you're not interested in looking at every single common ancestor, every single descendant. And then you have a polyphyletic group. A polyphyletic group includes an ancestor, all their descendants, and then somebody that's not a common descendant. You're interested in looking at something outside of just that one group. Maybe they come together because they're in a clade, they have similar characteristics. For this, it's, I don't know, your immediate family, and you know there's that person that you got that you call aunt or uncle that's not actually related to you? They would be included in this polyphylogeny. So taxonomists look at these in a lot of different ways, simply because, as we talked about, there are big problems with classification. So we're trying to sort everything out so it makes sense intuitively. All of these things look the same, they should belong together, but it turns out genetically it might not work that way.